boy Jam Tech, and today we'll be going over the series parallel circuit. The same circuit I told you guys I wanted to go over in the last video. Series parallel is just a circuit that fuses or combines the two circuits. If you don't remember what a series and a parallel circuit is, refer back to my last video. The link will be in the description. If you look here, you have a single resistor. I label that as R1. Over here, if you look closely, you have a series circuit. Well, you have two series circuits. R2 and R3, that's a series. R4 and R5 is a series. When you're doing any calculation and you want to find the total resistance, you have to first find the series, the total series in this parallel. So the first series, we could label this part here. We could label this part here as RA, and we can label this part as RB. To find the total, to find RA, which is the series, you'd say RA is equal to R2 plus R3. Remember, that's the formula for a series circuit. Now to find RB, now it would just be R4 plus R5. So RB, R4 plus R5. So that part's not hard. Just follow the fundamentals. Now, to get the series part of it now, to add these two resistance to get the total resistance right here, that would have to be done with the parallel circuit formula. And you know that states that 1 over the total resistance is 1 over R. In this case, will be RA plus 1 over RB. That would be the total resistance for this parallel right here. But to get the total resistance now, you have to incorporate back this R1 into the circuit. So to get the total resistance in the whole circuit now, that would be this, the total resistance that you get here. We could label that as, we can say RZ or RP. Let's use RP for the parallel. So the resistance, the total resistance when we're done calculate the parallel, that would be RP plus the R1 here. And that's because this here would be our RP, our total resistance here, plus our R1. So just follow the fundamentals. It's not hard. We're going to do a practice question now, and we'll see how it goes. Here's the practice question that I was talking about. So let's see how we can deal with it. Here you can see we have the same scenario where we have the R2 and the R3. We're given the values. And then over here, this is our R1, and we're given a current of 0.5 amps of current. And they're asking us to find the voltage. Now, we remember our triangle. If you don't remember this, go back to my last video. So to find voltage, it would be V equals current times resistance. So that's A times R for resistance. We know what A is. That's our current. So that would be 0.5. We don't know what R is. Look at all these R's. We don't know what R is. R here is the total resistance. We don't know that, so that's what we're going to have to find out now. So we're gonna have to tackle the series part of this parallel circuit here. And here we have R2 and R3, that's a series. R4 and R5 is a series. So let's tackle that. And we're gonna label this part of the series circuit as RA. So RA is equal to R2 plus R3. R2 is 2, so that's 2 ohms. Plus R3, 2 ohms as well. So that leaves us with 2 ohms. 4 ohms. So the total series circuit here has a resistance of 4 ohms, sorry. Moving on, we're gonna label this side as RB. So right here, the total resistance in this series circuit is RB. So we're gonna label that RB. That's R4 plus R5. Now that's equal to 5 and 6. So it's R4 is 5 ohms. R5 is 6 ohms. And that leaves us with 11 ohms of resistance. So right here we have 11 ohms, and up here we have 4 ohms. Now to get the total resistance in this complete parallel circuit, we have to use the parallel formula for the resistance, which we have to remember is 1 over, we're going to use RP like in the last part of the video. We're going to use RP as in total resistance in the parallel circuit is equal to 1 over RA, which is the total for the top part of the formula, RA plus 1 over RB. We know what RA is. RA is 4 ohms. We know what RB is 11. So we work out this, and we are left with 15 over 44. So 1 over RP is 15 over that. To get RP, we have to inverse this side of the formula. So to get RP, we would have to inverse this side of the formula, the -1. So bring in the trusty friend. So we can do it this way. We can say 15 divided by 44, and then we click inverse. So that's 2.9. So RP is equal to 2.9 ohms. That's the total resistance in the parallel. Remember, this is a parallel. So now we're going to have to incorporate the R1 now. Because since we know the total resistance of this is 2.9 ohms, now we're going to have to incorporate this. This now is a series circuit. This R1 and this RP is a series now. So now we're going to go back here, and we're going to say RT, the total resistance, is equal to R1 plus RP. RP is the total resistance in the parallel. R1 is just the resistance before the parallel. It's not hard. Just follow the fundamentals and you'll get it. R1 is 2 ohms. Jesus Christ, look at this. Oh boy. Hold on. Yeah. Plus RP, which is our 2.9. Yeah. That's what they made these calculators for, man. We don't burst our heads over these things again. 4.9 ohms of total. That's our total resistance. That's it, guys. Oh no. Tricked you there. We're looking for voltage. And that's the main thing. You need to remember what is the main reason or the main thing they're asking for in the questions. They're asking for the voltage, not the resistance. The resistance is just needed for the calculation. So now we know this is 4.9. And when you calculate that, that leaves you with 2.45 volts. Bam. It's not hard. I hope you like this video and please subscribe.